Yes, sir.
Right. The first step is I have to go for file, start new, do not read file. I will reset everything. We click yes. Next is I'll go for file, change my directory. Right, you choose a particular directory for where you want to save your file. So I'll choose something. Next, file, job name. So I'm going to change my name here. So this is beam problem. So I'll type as beam problem. Right, click OK. Next, title. So title, it is, I will call this as essays 3 or 4. I think 3, I think so. 3-beam problem. You can write something like this. And click OK. Okay. So first step is these 3 options. You have to complete this 4, right? Job name, directory, and title. You have to do this. Okay. Okay. So now we are completed. So hope last class Sarah used ANSYS 14 to solve that pipe problem, right? I am using ANSYS 20, right? So there are lots of problems related to elements. சில element இருக்காது அந்த மாதிரி பிரச்சனைகள்லாம் இருக்கு. So ANSYS 14க்கும் 20க்கும் நிறைய difference இருக்கு. I think most of you would have 20 latest version which is downloaded. So I'm going to use that and I will show you how to do this. Okay. So first step, go to preferences, select structural, click OK. So after this, so you have to go in this order. First complete your preprocessor, next solution, and then postprocessor. Now we'll go for preprocessor. First element type, click add here. Here you have different elements, right? So let me choose beam. When you go for beam, you have 2 elements, 2 node and 3 node. Right? When I say 2 node, it is beam 188. Right? So 188 is a serial number which is for ANSYS reference. Okay. Node 2 188. What it means is 1 element will have 2 nodes. Right, as you discussed in this FEA, it is like you have a trial function which is a0 plus a1x. That's it, right? a0 plus a1x. It's a linear element. Okay, so that is 188. So 3 node 189 is 1 element will have 3 nodes. So 2 nodes at the end and 1 node at the middle. So your trial function is a0 plus a1x plus a2x square. So it's a cubical element. So wherever you need some curves, right? So we can use this 3 nodal elements, right? So wherever you need only linear lines, you can go for 2 nodal element. Okay, you can use both. It doesn't matter. But we have this option. You always go for 2 node element, and you increase the number of elements. So that will be a better option when compared to choosing a 3 node element. Okay, so that is what we call as a H method and P method. So H method is increasing the number of elements, where P method is increasing the number of polynomials, like a0 plus a1x plus a2x square. So something like this. When you increase the number of polynomials, even though you get an accurate results, it takes lots of time to solve a problem because your matrix size is very larger in size. Okay, so we always use 2 node. Okay, I go for 2 node, right? One element la 2 node da irukum. So starting point only, ending point only. That's it. Okay, so you choose this, click OK. Right? So then click close. Okay. In previous ANSYS, older version, you have a real constant. You go for real constant and you can click this and it will be entered. Whereas in this, it is not applicable. You can click panalo work agad, right? Does not require carton, right? But how to do this, right? So in the real constant, inga sections lo, right? You go to sections. You have beam here, right? Choose beam. right? The sections is divided based on the type of element you are using. Link element use பண்ணீங்கன்னா linkல போயிட்டு you have to choose the section. Pipe element use பண்ணா pipeல போயிட்டு you have to choose. So now I am using beam element, so I will go for beam. When I go for beam, you have something called as common sections, custom sections, something like this. We are not going to discuss these things. You will go for common sections. When you go to common section, you get this data. So we have a tool here. It shows what is the ID, and you can also enter what type of section you want. It's for your reference. I will type it as rectangle. Right? So type of your element is here. You can choose whether you need a rectangle type of element, a C section, I section, L section, whatever sections you have, and it has a diagram here indicating what is the values. W2, you have to enter the value here, right? Based on this particular type of section you want, you can enter the value here. Okay, so our problem deals with, I think it is a rectangular section. You go to rectangle. Okay, so when you see go for rectangle, it shows this value. So BH, B and H. So that is a two value. NB and NH is, for example, if I want to change the centroidal location of my rectangle, I can enter this value NB and NH, right? So you can directly enter. Don't enter anything. You let it be 0. Okay. So for example, the central X location வந்து நான் கொஞ்சம் move பண்ணணும் 10 mm offset ஆகணும்னா I can give 10 here, right? It depends accordingly, right? H என்றது y direction. Okay, but now in my case you no need to change anything here. You have to change only the B value and H value, right? So the problem what I am going to use is we will solve problems in Newton and mm, right? We will use Newton and meter. Right, so which means I have to use meter, right, as my unit, and whatever force I have to substitute the values in terms of Newton. Okay, so this is my concept. So till the end, I have to follow this same unit. Okay, so for meter it is 0.2 and 0.3, right? So we'll go here. So breadth is 0.2. And your height is 0.3, right? Just click preview to look how it looks, so you can able to see here. So the move பண்ணீங்கன்னா தெரியும் IXX and IYY எல்லா வேல்யூவும் இதுலயே வந்துரும், right? Older versionல என்ன பண்ணனும்னா நீங்க IXX வேல்யூ என்டர் பண்ணனும், right? So BDQ.12 என்னன்னு சால்வ் பண்ணி என்டர் பண்ணனும். இங்க அப்படி தேவையில்லை. So all the values centroidal location வந்து எல்லாமே வந்து you will get it automatically, right, by just entering the cross section, beam order cross section dimension கொடுத்தீங்கன்னா போதும், right? Okay, you can click OK now, right? So we'll click OK, right? So now one section has been added. Okay, any doubt in this till now? Do you have any clarification till now? Can we proceed?
Yes, sir.
Okay. Now we completed element type and we choose real constant பதிலா section choose பண்ணிட்டேன், right? Next step is I have to go for material property. Let me go for material property. Material models, right? Structural, linear, elastic, isotropic. You need to enter the Young's modulus. So go here. I have to substitute in Newton and meter. So giga on the 10 power 9. So Pascal is Newton per meter square. So 210 into 10 power 9. That is what I have to enter. So let me go here. It is 210 E9. Okay. Poisson's ratio for two-dimensional problems only. Your Poisson's ratio is applicable. So mainly for three-dimensional problems. In the problem, applicable கிடையாது. போட்டாலும் போடாட்டினாலும் there is no change. But anyway, I am entering it. So 0.27 கொடுத்திருக்காங்கன்றனா enter பண்றேன். 0 கொடுத்தாலும் அதே ஆன்சர் தான் வரும். Right? And it closes. So I completed my material models. So still now I have done some process, right? Now I am going to model. When I want to model it, I can't able to create lots of nodes, right? You can able to see இப்போ shear force bending on diagram பார்த்தீங்கன்னா இப்போ இந்த இடத்துல வந்து இந்த ஸ்மூத்தா வருது, இந்த இடத்துல வந்து பார்த்தீங்கன்னா உங்களுக்கு இந்த ஸ்மூத்தான கர்வ் வரணும்னா உங்களுக்கு அத்தனை நோட்ஸ் இருக்கணும், ரைட்? ஒரு நோட்ல வந்து பீம் வந்து யூ ஷுட் நாட் டூ இட், ரைட்? For 8 meter I should have at least in the ஒரு டிஸ்டன்ஸ்க்கு I should have 20. So lots of points will have more smooth curve. Okay, so what I'm going to do is I'm going to create a key point first, then I have to create it as a line, then I'm going to mesh that. Okay, that is the way I'm going to do it, right? Okay, so I'll go for modeling, right? Create key points, inactive coordinate system. Don't enter these values, just click apply. So 0 0 apply actually. Next, for 2 meter, right? So I'm going to apply for 2 meter. Just type 2, apply. Next, for 4 meter, type 4, apply. Next, I think 2 meters over, 4 meters over, now 8 meter, right? So we go for 8. Click OK because it's my last point. Okay, I got this 1, 2, 3, 4 points, right? Any doubt in this? Any doubt in this?
No, sir.
Okay, now I am going to create it as a line. Okay, so go to lines, lines, straight line. So 1 and 4 connect பண்ணிடாதீங்க. So you should go like 1 and 2, 2, 3, 3, 4. Okay, so direct connect பண்ணா you won't get it. So அப்ப இந்த ரெண்டு key point யூஸ் பண்ண முடியாது, right? So start with 1, 2, then 2, 3, then 3, 4. It should say give different colors here, right? Then click OK, right? So still this is okay. So we have done a particular thing. So I believe that still up to this, whatever I have done is correct one. So I will go for save db, right? So நான் சொல்லியிருக்கேன், the save db is like undo option. So ஏதாவது தப்பா இருந்துச்சுன்னா redo பண்றதுக்கு we can use that. Okay, so I will go for save db. இப்போ இதுலயே வந்து I will show you what is the main purpose of this. Click the save db, it is saved. Okay, so நீங்க சேவ் பண்ணீங்களா இல்லையான்னு வெரிஃபை பண்ணனும்னா நீங்க வந்து இந்த அடுத்த டாப்ல பாத்தீங்கன்னா தெரியும். So data சேவ் ஆயிருக்குது, இங்க வந்து it will show, right? Okay, now go to meshing, right? நான் எல்லாமே mesh பண்ண போறதில்ல, right? I am going to mesh only one part because I should know what is my cross section, right? I should know what is my cross section. So what I am want to say is, when I mesh this, I should get like my rectangle should be like this, because 0.2 should be your breadth and 0.3 should be your height. For நம்ம mesh பண்ணும்போது தான் தெரியும் அது வந்து மேபி உங்க ரெக்டாங்கிள் இப்படியா கூட இருக்கலாம். So what I have drawn here, so இங்க வந்து 0.2 இங்க 0.3 இருக்க வாய்ப்புகள் இருக்கு. So which means the entire problem will go wrong. Okay, so அதை வந்து நம்ம வெரிஃபை பண்ணணும். அது வெரிஃபை பண்ணிட்டு தான் வந்து full mesh பண்ணணும், right? So let me do that. So I'm going for mesh tool, right? Set my line. So ஒரே ஒரு பார்ட் மட்டும் I'm going to take only 1, 2 line. So set line and select this alone. We click OK. So it is asking number of divisions. I want 20 divisions for this. We click OK. Still it is not meshed. Dotted line தான் காட்டுது, it is not meshed, right? So what I will do, again I will take that mesh tool. I click mesh, click that particular element and then click OK. So I have not meshed this two, I have meshed only one. Okay, click So now, and the one element is cut, so others has been removed. Right? Now, I will check this. Right? I will check this how the cross section is. So to do that, I will go for plot controls, style, size and shape. Click this. Right? Click this display element. Right? And you click this and then click OK. So now it shows an element. Right? So okay, let me change your view to isometric. Yeah. See here. Is this the right one? Is this the right element orientation? Yes. Can you tell me? Orientation correct irka?
No sir, illa nenikla sir.
Yeah, it is wrong. So actually this side should be 0.3. Right? This should be 0.2. So இது வந்து மாறி இருக்கு. Right? இதுதான் சொன்னேன். So இதெல்லாம் verify பண்ணும்போது தான் you can able to get the difference. So when I look in, you can able to see front view பார்க்கும்போது இப்படி இருக்கு. So for example, so நான் கரெக்டான view இல்லைனா you can also use this dynamic model mode. You can click and drag. Right? So right click பண்ணிட்டோம்னா I can able to see the rotation. I can able to rotate it. Okay? So பார்த்தீங்கன்னா your model is not perfect. It has to be oriented. Okay, you should rotate it to 90 degree. Okay, so that is the thing, right? So since the model is wrong, I'm going to delete that mesh. So I'll go to mesh, right? Your clear mesh. Okay, go to clear mesh, right? On lines, select this line. Select this particular line. அது மட்டும் தான் mention ஆகுது. So select that particular line, click OK. So now it has been removed. Okay. So the part has been removed. So the plot doesn't show here. It is empty here. So you don't think that all the data has been erased. So go to plot, click lines because still we are in line. Right? We have this. Okay. Right. In order to orient it, what I will do is I have to create one more key point. Right? To rotate that, I need one more key point. Right? So let me go for modeling now. Again, key point. Let me go for inactive coordinate system. That will be 0. Right? So here in y-axis, so for orientation purpose, I am going to enter a particular value which is 0.5 here. I think 1 is this one, right? Okay, 0.5 is enough. In any value, right? So in the screen, let me or value enter. That's it. So now I got this value. So I got this key point here. Okay, you can able to see here. 5th point is here. Okay, so this point is used for my orientation purpose, right? So I have not created any lines, so just one point, that's it. Okay, now I'll go for meshing, right? So I'll go for meshing, you go for mesh tool now. Let me select all the lines. Okay, so just a minute. Let me go for plot lines, which shows all the lines now. Now, mesh tool, set lines, select this line. Number of divisions should be 20. Okay. Next, similarly, I'm going to do for others also. Set this line. It should also be 20. Okay. Next, this line. Set for this line. So is on the 40. Right. I'll apply it accordingly. Click OK. So everything is done. Right? Now you go to mesh attributes, right? You go to mesh attributes. You have something called as default attributes and some other things, right? So you go for all lines, right? You go for all lines, right? Check what are your attributes you have. So you have your material number, your particular type of beam, You have a particular rectangle. Now you have something called as pick orientation key point. You just click this. This is very, very important, right? In order to orient it, I am using the key point to orient. Okay, so I am going to select this as yes. Okay, now click OK. So before meshing, so I am doing this before meshing, right? So mesh tool lo poi na enna kudutana element number division na kudutha. So this what particular line should be 20 divisions, 20 elements. So that is what I mentioned. Then I came here to mesh attributes. I selected all the lines, and then I chosen this checkbox. Okay, then we click OK. When I click OK, it is asking you, so what is that point? My point is somewhere here, right? So you can able to see here, right? So this is my point, fifth point. I'm choosing that. Okay, I'm choosing this. So you can able to see key point number is 5. It's showing correctly. Click OK. Now it has been oriented, right? So automatically it has been oriented. Now I'll mesh this. Mesh. Click mesh. So since I want to mesh everything, I will go for pick all. Right? Click pick all. So it is meshed properly, right? Let me rotate and see. Dynamic mode. Yeah, you can able to see here, right? So now my position, my orientation is being regular. So it is oriented accordingly, right? So the same thing can also be done for any type of section, say L section or I section. If you want to orient it, you click, you create a key point, click orientation, and then you turn it to 90 degree, right? Any doubt up to this? Yes.
Sir, meshing line set பண்ணீங்கல்ல sir.
ஆமாப்பா.
அது ஒரே ஒரு ரிப்பீட் பண்ணுவோம்.
So go to mesh tool, lines set, click set, select a particular line, click OK. It will ask you what is your value. You have to enter that value. That's it. Right? Okay. So you have two values here. Element length. Length is what is, if you know the exact length, 0.1 meter, you can enter it. Or number of divisions. You can choose, you can enter any one of this. Rendime enter panna error sollu. Right? You can enter any one of this, and then you can click OK. Yeah. Now, in order to avoid confusion, I am going to change this plot control again. So I'll just off this. Yeah. Right. So now you have got all the elements and other things. Right. So this part is over. Hope I have done till now. Whatever I have done is right. I'll go for save DB. Right. So இதுவே வந்து ப்ரீவியஸா நான் மெஷின்ல போய் delete பண்ணாம ரெசியூம் டிபி கொடுத்தாலும் நீங்க பழசு வந்துட்டு பண்ணிருக்கலாம், அப்படியும் பண்ணலாம். பட் ஜஸ்ட் ஃபார் ரெஃபரன்ஸ், மெஷ் நீங்க தப்பா பண்ணீங்கன்னா எப்படி பண்ணணும்ன்றதுனால தான் I came for that option. Right? Okay. So this is done. Now we'll go for solution. Right? We'll apply some loads. Go to loads, apply displacement. I'm going to fix this as a point. So go for key points. I don't want to go for nodes because there are lots of nodes here. Right? But key points only 4. I can easily identify. Right? That's why I go for key points. Go to key points, select this one and this one. Right? First and last. Click OK. So it is a simply supported beam. Right? Don't click all DOF. When I click all DOF, what happens is it becomes a fixed beam. Right? So there's a difference between that fixed beam and a simply supported beam. For simply supported beam, you have to fix X, Y, Z, RX. Okay? These are the 3 things you have to fix. Right? So this is the displacement, what you can see, and boundary conditions for a simply supported beam. If it is a fixed beam, you can go for all DOF, which means everything will be fixed. Right? So, and one more thing, don't use this R rotation Z rotation Z should be there. Even I can go this also. Even that also be a simply supported beam. But at least one rotation you have to fix. That's why I'm giving this. But RZ should be there because RZ is the moment in Z direction, right? That is all. That is the moment, right? Which has to be there. Okay. So I am fixing this UX, UY, UZ, and rotation X, and I click OK. Right? We can able to see here, right? Okay. Next, I'll go for loads. Let me go for force. Force on key points because then again it is easy for me, right? Go for key points. Click this key point, right? So this force is how much? 30 kilonewton. Okay. So click this. Click OK. It is Fy. Downward direction. So minus 30 E3 because I am solving in Newton and meter, right? So 30 kilonewton. Click OK. Right? Similarly, again, with this, go to this key point. Click OK. This is 20. Click OK. There are two loads, so apply. Okay. Next, I want to go for this, what you can say, UDL. So here comes the difficulty, right? So it has to start from here and has to end up to this, right? So just have in the mind that we created 20 element divisions here, 20 element divisions here, right? So and this is 40. When I select this, make sure you should have that 40 elements, right? So when you apply that UDL, right? So still now when I apply in key points, whereas now I have to apply in beam, right? So beam is an element which you have to choose. So there you may have that difficulty, right? Okay, I will save this at this location because I'm going to do in another way also, right? Same thing, I'm going to do it in another way also, right? For that, I'm saving it here. So go to pressure on beams. Click here. Now, in this pic, you have something called as single box polygon, something like this, right? And also you can enter the value here, right? If you know what is the particular item, right? So I don't know that, but anyway, I'll go for box. Go to click this box, select a box. I'm going to select it. Click and drag. You can able to see, and still I am pressing my left click, right? Clicking and dragging. So you can able to see total count is 41, which means I have picked something one extra, right? Let me zoom this. So to do zoom, I can press the zoom in button, right? And to view this, I can also click this. So I'll read. Yeah. Yes. Okay. So 41, which means I have picked one extra, right? What I'll do, I'll change this box to single now. Click this to unpick, and then select that particular node, last element. So now it is 40. So count is 40 now, right? So this is my overall element which I have to choose. Click OK. It is asking what is my I value and J value. Since it's a UDL, you should enter only I value. J value will be same. If it is a UVL, you enter two values here. One 0, other one is 50. You will get a UVL type of load. So in my case, you have only UDL, which is 10 kilonewton per meter, which is 10 into 10 per 3. Right? So I'll enter 10 E3. So no values for other things. Just click OK. So now you can able to see you apply that UDL, right? And sometimes you won't get this as a symbol. You will get in a different way. Don't worry. Anyway, that is also right. Okay. Now I'm zooming it. Fix this, right? So all the forces, whatever it is, I will apply. right? So any doubt in this forces, applying these forces?
Sir, during the constraining, for simply supported beam, we only need to constrain the y direction, right? Why are we like constraining all other like x, the rotations also?
No. Since it is a three-dimensional element, right?
Okay.
So you can't able to solve a problem without having that much of constraints. That is the reason, right? But as a part of a case, whenever
Could you repeat
we consider it's the thing is, so whenever we solve a problem, when you go for a three-dimensional figure, right, you have 6 degrees of freedom, right?
Yes, sir.
In order to solve that matrix, you should have some boundary conditions, extra boundary conditions, right? You consider in FEA you have a 6x6 matrix. What you will do to identify UX, UI value, at the end you will strike the rows and columns, right? So that is the usual method. So, but since it is a three-dimensional one, we have UX, UI, UZ, RX, RY, RZ, right? So it is not possible for the software to identify some boundary conditions. So that is why we are applying extra. We are applying extra boundary condition for three-dimensional objects. Okay,
sir.
So when you do in ANSYS 14, let me consider, when you do in ANSYS 14, you have an element called as beam 3. That is purely a two-dimensional element. Okay, in that case, you can apply only UI. It will work, right? Whereas here, it is not possible, right? So, and for this, the boundary condition has to be like that, right? Or are you getting it?
Yes, sir.
Yeah. So for 3D, you should do this, right? Solve the problem. You won't get that. Okay, that is the purpose. Okay, so now we apply the loads. All the data are done. Only thing is I have to solve. Go to solve. Current load step. Click OK. So your solution is done. Click close. Close. Go to general post-processor. So this is over. Let me go for general post-processor. Go to plot results. Nodal solution. So UX, UI, I want what is my displacement in Y, or use some displacement along with undeformed edge. Click OK. So you get this. So you are getting 0.0074, right, meter, right? It's around 7.4 mm deflection, right? So that is the deflection which is formed here, right? Similarly, we will go for stress. Right? I think stress won't work. I have to press that. Okay. Right. Right. So, any doubt after this? Finding this result. Yeah. Next step is, if you want to identify the stress values, right? Deformation one day. But if you want to identify the stress values, in ANSYS 20, you have to go to read results, click last set, right? Click last set. Last set na kadasiya vanda result read panna soludhu, right? So read panna you will get what is your stresses and all. So for that only I go here, read results, click last result, last set. Now go to plot results, control plot, stress. I'll go for this one, Mrs. Yeah, you're getting. So hope so stress here. It is not showing anything, right? But there is some stress values which you can't able to see it here, right? Only thing is I have to do through this one. You can go to list. Instead of this one, I will go for list results, right? Nodal solution, stress moduluses. What I am doing here is I don't want to plot. Plot வந்து இதுல வராது, right? I'm going to list it. Okay. Okay, saying that there's no data. Okay, maybe it will be inside. I will take it out. Okay. So next step is I'm going to add this. I'm going to draw this shear force and bending moment diagrams. Right. In order to do that, it is extra thing which has to be included in this element table. Right. So as like your general post-processor, you have an element table which has to be included. So extra a shear force or bending moment diagrams, it has to be included through this value. Right. So what I will do is I have to verify what will be the particular code for getting the data for shear force and bending moment. So let me go for help. Click help topics, and I click help topics. It opens help. Let me consider. I think yeah. So it opens an ANSYS help like this, right? So you go here. Go to element reference. Click element reference. Right? So you have element library. Click element library. It shows lots of numbers. Of course, the last number indicates your serial number. I choose the beam 188. So you go for 188 serial number. 188, you have 188 here. So I will show the difference here. So you can able to see here. This is beam 188. So node 1, node 2, linear. Okay. So when I go for beam 189, see 1, 2, 3. So center you have one more node. Right, that is the difference. That's it. Okay, I will go for that same. Go to beam 188. Go down. And you come down, you can able to see some what I can say, symbols which is used for a particular type of values. Stress values. Yeah, here it is. EL. Whenever I say it is EL, it is element number. So I don't want that at all. You can able to see here. Shear force, SF. SFY, SFZ. Right? We call that as shear force. Shear strain is SE. We don't want that. Leave it. Right? And I want shear force. Right? And we go down. I want to check whether where is that bending moment. Yeah, your bending moment here, which is MY, MZ, right? So these are the two datas, and of course you can able to see a bending stress what we identified. So TBYT is right? One thing what I want to say is usually when I identify shear stress, shear force is in y-axis, right? That is 100% sure, right? Shear force always in y-axis, but moment, bending moment is always in z-axis, right? So that is the real part. But in the ANSYS 14, in the entry entry right? Right? So shear Z in the maybe they have missed something. SF Z it is showing correct value, right? Similarly, MY correct value, right? So I don't know. So in the so MY FY right? So they maybe have misuse or something like that. So I don't know what is this. But ANSYS correct in the ANSYS I don't know. There is a small difference. So since I have verified it, I am going to choose SF Z. Okay. S of Y கிடையாது. So have a note, S of Z. Shear force in Z direction. Actually, this is Y direction. Right? இது மிஸ்டேக்கா தவறுதலா போட்டாங்கன்னு தெரியல. ஆக்சுவலா ஆர்டரா வரும்போது Y Z தப்பா வந்துச்சு என்னன்னு தெரியல. I don't know. Right? So for this, I have to use SMIC 5,18. Right? So these are the values I have to enter. So this is for shear force. Let me do this and then we will come back for bending moment. Okay? Shear force is 5,18. Go here. Go to element table. Define table. Add. So I'm going to use a label SF at the nodal point I. Okay. So I'll do I for I. Okay, so here call this. I'll go to my sequence number. So SMISC, enter 5. Click apply. Similarly, SF at nodal point J. Go to SMIC. Same. It is I think 80. Right? Click OK. So I have included this 5 and 80. You can verify it here. So it is 5 and 80. Similarly, for bending moment, it is 2 and 15. Right? SMIC 2 and 15. Bending moment at Y. So I'll add it. So BM hyphen I. SMIC 2. Apply. Similarly, BMJ SMIC 15. Okay. Right? So we have included shear force and bending moment. Still, we can also see that stress. I think what is the name for the stress? Bending stress. I don't know the notation. Let me go. Bending stress is SBYT something. SBYT, SBYB, right? Or SBZ something. Okay. Okay, let me try it out. So SBYT is, we scroll down. Yeah, you have SBYT, right? Which is 32 and 37. So I will put only 132. That is enough. No require, because it's an elemental solution. 32 and 37 will get the same value, right? So SBYT is 32. Let me enter that alone. Add. So this is B stress. What is that? Sorry, forgot. This 32. Right? Let me click OK. So I added. Okay. So I completed everything. I have made a table. So for shear force, I node, J node, bending moment I node, J node, and also for bending stress. Right? Any doubt to this? Up to this? Yeah. Okay, we'll proceed. Let me close. Now I'll go to plot results. Contour plot. Line element RES. Right? Whenever you go for a nodal type of solution, we go for this line element. Element type of solution, you go for line element table. Right? I'll go for this. Select the first one. Node I should be S of I and node J should be S of J. Right? Undeform the shape. Right? And optional factor, you put -1 because in US and all, they will consider upward as negative and upward as positive and downward as negative. So கொஞ்சம் alternate ஆகணும். So நம்ம ரிசல்ட்டுக்கு ஏற்ற மாதிரினா -1 போட்டுக்கலாம். That's it. Click OK. Right? I can able to see here. Right? So இது மேலே வரும். So minus level plus it will be like this, nothing else. So you can able to see. So this is the bending shear force diagram, what we got. I'll get the same type of diagram here also, right? So the maximum is 47. So this is the value 47, right? Which is the reaction value, right? Any doubt on this? So what you'll do, you have to go to plot controls, right? Meta file data, invert black or white. So this is one plot. You can save this as shear force diagram. So shear force, you can save it here. Next, click again, line element reference, change it to bending moment. BMBJ, right? Click OK. Right? Minus pota, this is plus. You change accordingly. You manipulate it accordingly, right? Doesn't matter. You can able to see here. This is my curve. You can able to see you get a smooth curve here because I have chosen 40 elements here, right? Over element represent பண்ணுது. If the element is lesser, you won't get this much smooth. It will be somewhat in a different way. Okay, that is this. So again, you can also save this. Go to this, and this is instead of shear force, it is bending moment. Right? Now I go for bending stress. Let me click bending stress. Element table, because it's an element type of approach. So go for element table. Choose B stress. I don't know exactly Varma therila, but anyway, yeah. You're getting 0.48 into 10 power minus 9 Newton per meter square. I don't know. Correct. So what we got is, I think, 36. Maybe now y எடுத்ததனால அப்படி இருக்குமோ தெரியல. Maybe I will take x and let me z எடுத்து பார்ப்போம். So நம்ம y எடுத்தோம் 32 போட்டோம். Right? Z எடுத்து பார்ப்போம். Z னா 34 வரணும். Okay, let me check it out. I don't know exactly. Go to element table, define, add. So we call this as BS 34. I think it is 34, right? Yeah, 34. Okay. Let me check it out. Yeah, here it is around 70. Still, I'm not getting it correctly. Okay. All right. I can also verify in a different way. Right. So this is one way of identifying my stress, right? So bending stress. இல்லைனா வந்து வாட் மெசேஜ் ஸ்ட்ரெஸ் வழியா அப்படின்னா லிஸ்ட்ல போய் I think you can able to get it. List, result, nodal solution. I think I'm go for this one. This is oh, it is not coming. Okay, list, results. This element table data. So what we identified, I want this bending stress and this two. And we select this two, click OK. I'll get the list to find out each element what will be the stress which is developed. Right? Maybe. Yeah, varlan theriyala. Okay. I don't know exactly. So, so I verified it actually. So, so it is 36.66. If I add 3 more, sorry, let me do that also. 37 போட்டு பார்க்கலாம். 33, 38. Okay, 35, 40, 35. Let me tie it out with 35. Yeah, I think it is 36.6 approximately we are getting. Because this is a Newton meter, I am solving, my answer is in Newton mm. Hope I think we are nearer to it. But you can able to see here. Sorry. So 36 Newton meter means it is around 36.66 into 10 power 6. So it is 0.36 into 10 power 8. I think it is right. So you can also do this by go for plot controls. You can go for style. You can also change this to look. Sorry. Yeah, I'll go for this is in element table. So go to plot results, model solution, where deformed plots. Right, you can able to see here. Right, so this is how deformation is. Right. So you animate pani pakla. So you have an option here also, animate deformed results. So you can also go for what is the animation here for a particular time. Right? So how it bends. Okay, any doubt on this? Any doubt?